We might have just found chemical signs of life on a planet only 120 light-years away. NASA's James Webb Space Telescope has detected something in the atmosphere of a distant exoplanet, a molecule that is only produced by living organisms, mainly microscopic life in our oceans. This could be the first real evidence that life exists beyond Earth. We talk about the exoplanet K2-18b, which orbits a red dwarf star in the constellation Leo. It's about 8.6 times the mass of Earth and nearly 2.6 times our planet's radius, which makes it a sub-Neptune, a type of planet that doesn't exist in our solar system. It's located in the habitable zone of its star, meaning temperatures could allow liquid water to exist. But here's the twist. K2-18b is likely covered by a thick atmosphere rich in hydrogen and may have a deep ocean beneath it. Life, at least as we know it, depends on a very narrow set of conditions. You need liquid water, stable temperatures over long periods of time, the right chemical elements like carbon, nitrogen, and phosphorus, and a source of energy. On top of that, the planet's atmosphere has to be thick enough to protect against harmful radiation, but not so thick that it traps too much heat. Even if all these conditions are present, they must remain stable for millions, sometimes billions of years for complex life to develop. That combination of factors is rare, which is why finding even a hint of life-supporting chemistry on another planet is so significant.
Even the odds are so small. K2-18b might have all of these aspects which are required for life.
Now the proof of existing life. The James Webb Space Telescope analyzed the light from K2-18b as it passed in front of its star. This is called transit spectroscopy. When starlight passes through the planet's atmosphere, molecules in the atmosphere absorb specific wavelengths of light. Webb's instruments can detect these tiny absorption patterns and tell us what gases are present.
In the latest observations, Webb detected methane, carbon dioxide, and possibly dimethyl sulfide. Methane and carbon dioxide together suggest a possible carbon-based chemical cycle. The DMS detection is the most controversial part because on Earth, almost all DMS comes from living organisms, specifically phytoplankton. DMS is released into the atmosphere when these organisms die or are eaten, and it plays a role in cloud formation by helping water vapor condense. In non-biological environments, DMS is extremely rare because it breaks down quickly and needs specific organic chemical reactions to form. Detecting it on another planet raises the question, could there be biological activity similar to what we see in Earth's oceans?
So, what life forms could exist there? If K2-18b truly has an ocean and an atmosphere rich in hydrogen with traces of DMS, the possibilities for life are wide-ranging. Conditions might support microorganisms similar to Earth's plankton, which could produce gases like DMS. But given the planet's larger size, higher gravity, and different atmospheric composition, life could also have evolved in forms unlike anything on Earth. In a hydrogen-rich atmosphere, biology might favor chemical processes that are rare here. If the ocean is deep and shielded from harmful radiation by thick clouds, more complex aquatic organisms could potentially thrive.
So, can we even travel to this planet to confirm life? Right now, K2-18b is about 120 light-years away, far beyond the reach of our current spacecraft. With today's technology, such a trip would take millions of years. But in the far future, time dilation, a concept from Einstein's theory of relativity, might change the situation for the travelers themselves. If a spaceship could move at speeds close to the speed of light, time on board would pass much slower compared to time on Earth. The crew might experience the journey as only a few years, even though centuries pass back home. This wouldn't make the trip shorter for people on Earth, but it could make interstellar exploration possible for those who travel. While still far from reality, this concept keeps the door open for the idea that one day, humans or their distant descendants might see K2-18b up close.
I am very interested in your opinion. Do you think life exists there? Or do you even think we are alone in the whole universe? If you want to learn more about time and time travel, here is another video I recommend.
See you in the next video.